Hey guys, Mr. Larson here. I'm going to walk you guys through 2.7, which is solving rational inequalities. Um, Today we're going to take the approach of finding critical values and then setting up a number line and picking test values in each interval and then determining if that interval is a solution or not. Okay, so this is pretty similar to last chapter when we were solving polynomial inequalities. We also solve polynomial inequalities from a graphical standpoint. So that's technically another approach you could take here. You could graph these rational functions and then just determine when it's positive or negative, depending on what the inequality sign is. But if we're going to do it from an algebraic standpoint, from this critical value standpoint, you have to follow these 5 steps. Okay. If you guys remember from earlier in the week when we were solving rational equations, we kind of had those 3 options. But from an algebraic standpoint, if you're solving a rational inequality, you only can do it this one way. All right, and that's to get all the terms to one side. So that's the first step. Second thing you're going to do is find the lowest common denominator and get it to be a single fraction. You need one fraction on the left side and then 0 on the right side. Okay. So once we get to that point, once we have our fraction on the left-hand side, we want to set the numerator equal to 0 and solve for x. That's going to generate some critical values. And then you do the same to the denominator, set that equal to 0 and solve for x. And that's the other part of your critical values. Okay, so you'll be getting critical values from the top and the bottom. Once you find those critical values, we'll set up a number line and we will test each interval. Okay, so I have 3 problems I'll work through with you. And then we'll have some practice for you. All right, so number 1 over x is less than or equal to 3. First thing I want to do is subtract 3 from each side. And then I want to create one fraction on the left side, so I want to get a common denominator of x. So I multiply -3 by x on the top and bottom. That's going to give me 1 minus 3x over x is less than or equal to 0. So I have achieved the first 2, right? I got everything to one side, got a single fraction. Now the next 2 steps are involving your critical values. Critical values are really just zeros from the numerator, zeros from the denominator. So let's keep in mind which ones come from what spot. So from the numerator, if I set 1 minus 3x equal to 0, I get x equals 1 over 3. And from the denominator, it's simply x equals 0. So now we want to set up a number line, and let's list these 2 critical values, 0 and 1/3. And my inequality sign, this less than or equal to, if I have an equal sign underneath, that means that I'm talking about filled in circles at my critical values. Okay, so first let me just draw my circles. That line underneath, the equal sign underneath, means we're coloring these in, right? We're including those values. But bear with me after we do this, okay? I want to explain something. So these means that 0 and 1/3 are going to be included in our solution set, okay? But now let's think about this. If I included 0 in my solution set, which actually comes from the denominator, so I'd have 1 minus 3x over 0. I don't think that's going to generate a solution, right? So actually, I'm going to take back what I said here. Any critical values generated from the denominator will always have an open circle. They will never be included, because if they were included, it would generate an undefined value for your fraction. Okay, so regardless of whether you have an equal sign or not underneath your inequality sign, you're always going to leave the critical values from the denominator as open circles. Okay, the critical values from the numerator will be determined by whether you have an equal sign or not. So I will color the circle in for 1/3. Okay. All right, so now I want to pick some test values in between each of these sections. So let's see, we'll do 1/4 in here. And we'll pick 1 over here. And now I'm just going to plug each of these in, right? So if I plug in -1, I get 4 over -1, which is -4. And is that less than or equal to 0? That's true, right? So this area will be included in my solution set. Now let's try 1/4. So that's going to give me 1 minus 3/4, which is 1/4 over 1/4. Well, that's equal to 1. Is that less than or equal to 0? Maybe I should put question marks here. That is not. Okay, so this area in the middle is not included in my solution set. Finally, we'll try the number 1. That's going to give me -2 over 1. Is that less than or equal to 0? It is. So this will be included in my solution set. So I have 2 intervals. My solutions will be from -infinity to 0, and then including 1/3 all the way to positive infinity. Okay? Okay, next one. So let's subtract 5 from each side. I get x plus 6 over x plus 1 minus 5. And then I want to multiply by x plus 1 over x plus 1. This whole thing is greater than 0. So I would recommend combining everything into one fraction before distributing. And that's going to potentially save you from having any, especially if this is a minus sign here, it's going to potentially save you from having some incorrect signs on some of those terms. So I would have x plus 6 minus 5 times x plus 1 all over x plus 1 is greater than 0. Now I can distribute and -5x minus 5. And let's combine. So x minus 5x is -4x. 6 minus 5, positive 1 over x plus 1. Okay, now let's talk about critical values. So from my numerator, I get 1/4. And from the denominator, we get x equals -1. So let's set those up on the number line. Like we talked about, any critical value generated from the denominator will have an open circle because we cannot include a number that generates 0 on the denominator. And then for the numerator, all those critical values, we will look at our sign. And I don't have an equal sign, so that's also on this one going to be an open circle. Test values. Always pick 0 when you can. 1's another easy one. I like to pick mostly just integer values. And we will plug these values in and see what happens. So, by the way, let me finish writing this. This is greater than 0. Here's kind of a shortcut, and if you're not ready for this, that's fine. But all we really need to know is this test value going to generate a positive or a negative number? And that's enough to determine if I'm going to be greater than 0, right? So you don't even really need to know the exact value. You just need to know, okay, well, is it going to be bigger or less than 0? And that'll tell you if it's going to be a true or false statement. Okay, so when I plug in -2, -4 times -2 is positive 8 plus another one. That's going to give me a positive number on the numerator. And on the bottom, -2 plus 1 is -1. That's a negative number on the denominator. When I simplify that, it'll be a negative number. And is that going to be greater than 0? No. So you can probably just find the exact values. I'm just showing you on a manageable example how we can just think positive versus negative on the numerator and denominator. So let me plug in 0. When I plug in 0, well, it's not even worth doing positive or negative because it's just 1 over 1. 1, is that greater than 0? That's true. So the area including 0 will be part of my solution. Lastly, we can plug in 1. When I plug in 1, I get negative 4 plus 1. That's a negative number. And when I plug in 1, 1 plus 1 is 2. That's a positive number. Negative divided by a positive is a negative. Is that ever going to be greater than 0? Of course not. So this area is not included. So it looks like my solution area is going to be from negative 1 to positive 1/4, both with parentheses. Okay. This one I don't know if I'll finish, so if not, then you guys can finish it off and take a look at the key. Try to work quickly. Okay, so we can see 3 critical values. Again, anything generated from the denominator is always going to be an open circle. So negative 5 and 3 will be open circles. And from the numerator, that's when I pay attention to the sign. So I have an equal sign there. So 5 will automatically be included. We fill that in. Let's pick some test values. Let's plug them in. So I'm going to use my positive or negative approach. So 4 times negative 6 is negative 24. Subtracting 20 more, that's definitely a negative number on the bottom. Negative 6 plus 5, that's a negative number. Negative 6 minus 3 is another negative number. So I have a positive on the bottom now, right? So negative over a positive gives me a negative. Is that greater than or equal to 0? No, that's false. Plugging in 0, I get a negative. On the bottom, I get a positive times a negative. So that's a negative on the bottom, right? Negative over negative is a positive. So that will be greater than or equal to 0. This is included. Let's see, running out of space. Plugging in 4. 4 times 4 is 16 minus 20. That's a negative on the top. 4 plus 5 is a positive. 4 minus 3 is positive. Negative over positive is negative. Is that greater than or equal to 0? Nope. Last, we'll plug in 6. 4 times 6 is 24 minus 20. That's a positive on top. Times positive and positive. So this looks like it'll be true. Okay, so you guys can check the key for the answer in interval solution.